everybody would have factorized this fella and get 3x minus 8 into x plus 1. Now, whenever we are solving a quadratic, all quadratics are of the form ax squared plus bx plus c, but we have an equal to 0 on the end. So, for example, if I had a quadratic 3x squared minus 5x minus 8 is equal to 0, in order to solve this quadratic, I need to factorize it first, which you all just did. I factorize and I get 3x take away 8 into x plus 1 is equal to 0. After I factorize, and I have to put it equal to 0, all you have to do is put each bracket equal to 0. My first bracket is 3x minus 8 is 0. Always write the words or x plus 1 is equal to 0. And from here, we solve for the unknown. I think I would have run through the steps in solving equations for you guys, where we move the terms around and then simplify both sides and divide by the coefficient of the variable. So for 3x, take away 8 is equal to 0. If you all can't remember, go back and watch that video. You all have access to it. I'll have to move the 8 across. 3x is equal to 8. And then I'll divide by 3 on both sides. And x will be equal to 8 divided by 3. For x plus 1 is equal to 0, I'll move the 1 on the next side and I'll get x is equal to minus 1. And that is it. That's it. You all think you all understand that to perform it on another question? Everybody?
Yes, sir.
Samir,
Yes,
Sedan, Tyrese.
Yes, sir.
All right. Now, the problem here, well, not here, but the problem in questions is the quadratic does not look like this. The quadratic doesn't look like that. But fellas, as soon as I see a x squared and an equal sign in the same equation, brother man, is a quadratic. You have to move about things, just like how I will move about things to solve an equation. I'll have to move about things to solve a quadratic and make it look like a x squared, a x, and a constant is equal to 0. So for now, let me see how we can make something look like a quadratic. If I have 4x plus 3 is equal to 2x minus 8x squared. Well, the first thing I notice here, I have a x squared and it's an equation. Well, let's see in that. I want to try and make this equation look like a quadratic equation. And a quadratic equation looks like ax squared plus bx plus c is equal to 0. So what I'll do here, and I'll do the first example, I will move everything on the left. Every single thing, I'll move it on the left. I'll move the 8x squared. I'll get positive 8x squared. The 4x and the 3 remains on the left. It was plus 4x plus 3. And the 2x moves across, becoming minus 2x. Now, I moved everything on the left. So I have nothing left on the right. And we represent nothing with 0. You have to put equal to 0. Over here, I could simplify it. 4x squared. The 4x and the 2x, that will be 4 minus 2 is 2x plus 3 is equal to 0. So I started off with something that doesn't look like a quadratic equation, and I make it look like a quadratic equation where I could factorize and solve. Now, the purpose of these questions now, for now, is just to practice moving around things and making it look like a quadratic equation. And this will be very helpful when we have simultaneous equations to solve where one is linear, one is nonlinear, to move about things to make it look like a quadratic and solve. So I want all to just move around this for me and tell me what you all will get as a quadratic. If I have 4 minus 11x squared plus 2x is equal to 8 plus 3x minus. I put 2x squared now. Move about this to make it look like a quadratic for me as quickly as possible. All right, so 4 minus 11x squared plus 2x remains on the left. I'll move the 8, it becomes minus 8. I'll move the 3x, it becomes minus 3x. I'll move the minus 2x squared, it becomes plus 2x squared. And I remain with nothing on the right. Now I can add the x squareds to the x squareds, x's to the x's, and so on. So I can do that here. I have minus 11x squared plus 2x squared. I have 2x minus 3x, and I have 4 minus 8. So I can add those terms together. Minus 11 plus 2 is minus 9x squared. 2 take away 3 is minus x. And 4 take away 8 is minus 4 is equal to 0. Yeah? You're comfortable with that?
Yes, sir.
Wonderful. In the video I sent on simultaneous equations using the method of substitution, we have to substitute our value for y into another equation most of the time. Most of the time, we'll substitute one equation into another equation. So we have to make that equation for simultaneous equations where one is linear, one is nonlinear. We have to make that equation look like a quadratic. Ax squared plus bx plus c is equal to 0. A nice example is this. If I have 2x plus 1 squared plus 3 into 2x minus 4 plus 2 is equal to 0, we have to make this look like a quadratic. So I have a question here. Will anybody find trouble in expanding this? I'll put a disclaimer out there. 2x plus 1 squared is not 4x squared plus 1. All right? It's not that. So I'll ask again. Will anybody see trouble in expanding this? Okay? Will anybody? Nobody should see trouble in expanding out this bracket here. Nobody. Let me throw it in the punch bowl, and I put in this is equal to minus 2. So for number 4, what I want you all to do now, I mean, it doesn't look like I have an x squared inside of here anyway. It doesn't look like that. So how do I know this is a quadratic to make it look like ax squared plus bx plus c is equal to 0? Anytime you have a bracket in any question, it hides the true nature of the equation. Because right now, if you all go under the fact that if the highest power of the variable is 1, then it's a linear. If the highest power of the variable is 2, then it's a quadratic. Over here, as it stands, it looks like the highest power of the variables is 1. Because this is a 1 on the x, and this is an x1 on the x. But the brackets, especially the squared bracket, indicates that this is not really 2x plus 1. When I expand it out, I will end up getting a squared term inside of this expansion. So when you expand it out and rearrange, I want everybody take a couple minutes, do this one, and tell me what you all will get for this quadratic. Now you will encounter questions like this for simultaneous equations where one is linear and one is non-linear. So how do we approach questions like this? And this is how I will personally like students to do the working for these questions. Draw a little working column, and whatever expansions you have to do it in the working column. One, it makes life a bit easier for a teacher to understand what you're doing, and it makes life a little easier when you're writing your work visually. So in my working column, I'll have 2x plus 1 squared. Now there's a shortcut to expand two terms in a bracket squared, but we could do the long cut first. The long cut is, this is 2x plus 1 multiplied by 2x plus 1. And everybody should be comfortable with the distributive law, where I'll have the first thing in the first bracket multiplied by the second bracket, then the second thing in the first bracket multiplied by the second bracket. This is 4x squared plus 2x plus 2x plus 1, which is 4x squared plus 4x plus 1. So my brackets is 4x squared plus 4x plus 1 plus, this should be easy to expand. 6x take away 12, move the 2 across, plus 2 is equal to 0. From here, should be cake. I have nothing to add to the 4x squared. I have no other x squared terms. I have a 4x here, I have a 6x here, and I have a plus 1 minus 12 plus 2. So my answer is going to be 4x squared plus 10x. 1 take away 12 is minus 11. Minus 11 plus 2 is minus 9. Is equal to 0. 4x squared plus 10x minus 9 is 0. All right. Good. So I see only one of you all didn't get correct for the answers I get. This is the shortcut to expand a square brackets. And pay attention if you want to know this, right? If I have any two terms in a bracket, let's say I have A plus B, and I have a square on top here. To expand this shortcut, I'll square the first term. I'll multiply the two terms by each other, A by B, which is AB, and then I'll multiply it by 2. That could be plus 2AB, and I'll square the last term, plus B squared. Now you have to be careful when the sign separating them is a negative. So let me do an example here. Let me say I have x plus 3 squared, where the law says square the first term, that will be x squared, multiply the two terms by each other, x by 3, and then multiply it by 2. X by 3 by 2 is 6x, and then I square the last term and I get plus 9. Let me do this 2x plus 1 squared. 2x plus 1 squared. I will square the first term. The first term is 2x. So when I square the whole first term, I'll get 2x all squared. Multiply the two terms by each other. 2x by 1 is 2x, and then multiply by 2. Plus 4x. And square the last term, I get plus 1. 2x all squared. Square the 2 square the x plus 4x plus 1. Now the dilemma is, well, it's not really a dilemma, is a little paying attention. You'll have to pay attention, is when I have a minus sign separating the terms. Let me say I have 3x take away 2 all squared. The procedure is the same. Square the first term. When I square the first term, it'll be 3x all squared, which is 3 squared x squared, which is 9x squared. Multiply the two terms by each other. Now the two terms are 3 and minus 2. 3 multiplied by minus 2 is minus 6. So 3x multiplied by minus 2 is minus 6x. Minus 6x, I'll have to multiply that by 2 now. I'll get minus 12x. And when I square the last term, I'll get plus 4. When you square the first term and you square the last term, just a little side note, you will always get a positive number. Always. The first term squared will always be positive. The last term squared will always be positive. Depending on the sign on the middle term, it could either be positive or negative. So with that in mind, let's try another one. 5. And obviously, I'm going to try minus sign inside of here now. If I have 3x take away 4 squared plus 7 into 2x minus 3 is equal to, I'm given a little bit of work to do, 4x plus 2 all squared minus 1. I'm given a little bit of work to do. And this is my advice for you guys. Before you decide to move things around, expand all brackets first. Leave them where they are, expand all brackets, then look to move them around. Understood? So try a thing. If you'll need me to jump in, I'll jump in. If you're not so confident with the shortcut, use the long cut. I did the long cut in number 4, where I have the bracket by the bracket. If anywhere you're unsure about what to do, you need to just let me know. So organize. So for this one, if you use the shortcut, no problem. If you use the long cut, no problem. I'm going to use the shortcut for both squared brackets. When I use the shortcut for the square bracket on the left, I have to square the first term, which will work out to be 9x squared. When I multiply the two terms by each other, 3x by minus 4 is minus 12x. And then I multiply that by 2. I'll get minus 24x. And the last term squared is going to be plus 16. Plus 14x take away 21 is equal to, same thing again in the right-hand side. Square the first term, it will be 4x all squared, which will be 16x squared. Multiply the two terms by each other. 4 2s are 8. That will be 8x. Double it. 8x by 2 is 16x. And square the last term, I get plus 4 minus 1. Move things around. Now, in this case, I wouldn't just move it around helter-skelter. I will start to move it around in a little order. I'll put my x's next to the x's, x squares next to the x squareds, and so on. So 9x squared, I'll move the 16, x squared, I get minus 16x squared, minus 24x plus 14x, move the 16, I get minus 16x. On the left, I had plus 16 minus 21. On the right, I have plus 4 minus 1. Move the plus 4, becomes minus 4. Move the minus 1, it becomes plus 1, is equal to 0. 9 minus 16 is 7, minus 7x squared. 24 plus 14 is 38. I'm sorry, minus 24 plus 14 will be minus 10. Minus 10 minus 16 is minus 26x. Minus 21 minus 4 is minus 25. Minus 25 plus 1 is minus 24. Is equal to 0. See, now I get minus 8. Making me think I make a mistake somewhere. 16 minus 21. What did I have? 16 minus 20. Oh, I forget the 16. 16 take away 21 is minus 5. Yeah. Minus 5 minus 4 is minus 9. Minus 9 plus 1 is minus 8. So it is minus 8. Cool. So I make a mistake and I leave out the 16. Are you guys comfortable on that?
Yes, sir.
Alejandro?
Yes, so all I have to remember is to do the column thing on the side.
Well, your working column, right? Your working column is there if you decide to expand it how I expanded it over here. Cool? You could do it either way. And with the practice, you will get good. Now, let me tackle a pair of simultaneous equations and see how this is being applied in simultaneous equations. Now, if I have two simultaneous equations, one linear, one nonlinear, it will be very, very straightforward. One will be y is equal to, let me say, 3x squared plus 4x minus 9. And the next one, y is equal to 2x minus 5. From the videos, I did say, let the first equation be 1, let the second equation be 2, that's your first step. In both equations, I have y is equal to something. Yeah? When I have y is equal to something, I have it in both equations. I can substitute 1 into 2. And again, this should be straightforward because you all got the videos on this already. When I substitute 1 into 2, I'll get 3x squared plus 4x minus 9 is 2x minus 5. It is looking like a quadratic equation as yet. So I had to move things around. I'll end up with 3x squared plus 4x minus 2x minus 9 plus 5 is equal to 0. 3x squared plus 2x minus 4 is equal to 0. How we decide to solve this? We will organize. For now, all we know how to solve is to factorize by grouping and solve. There's another way to solve quadratics, and we have to learn it. Let me do our next example. Let me say this time, I have y is equal to 3x squared plus 2x minus 1. And for the next equation, I have x is equal to 2y plus 4. I'll let both equations be 1 and 2. Now it's entirely your choice, all right? I highly doubt a question for CXC is going to come like this. Questions for CXC are going to come like the first example on the left. But in the event a question comes like this, I can do one of two things. I have y is equal to something, and then I have x is equal to something. I can either substitute 1 into 2, and wherever I see y, I put 3x squared plus 2x minus 1. And wherever I see x, if I'm substituting 2 into 1, wherever I see x, I'll put 2y plus 4. For the sake of practice, I'm going to substitute 2 into equation 1. Substitute 2 into 1. So y will be equal to 3 into x, and x is 2y plus 4 squared plus 2 into 2y plus 4 minus 1. In all simultaneous equations questions, after you do your substitution step, after you do your elimination step, you have to have only one variable in the question. So if you notice, in the question itself, I have two variables, x and y in both equations. After my substitution step, I ended up with one variable, which is x. In the second example, again, in the first two equations, I had x's and y's in my both equations. After my substitution step, I had one variable. So all the work for me now is to expand this and make it look like a quadratic. A little piece of advice, if I have, I just taken a step back, right? Let's take the 2x plus 1 squared. We have the expansion to 2x plus 1 squared. Let me just see, right? Let me just see. I had 3 into 2x plus 1 squared. What I'll do, expand the squared first. So this will be 3 into 4x squared plus 4x plus 1. Then expand it using the 3. I'll get 12x squared plus 12x plus 3. So over here, I'll expand the 2y plus 4 all squared. I'll expand that first. Then I'll multiply it by 3. So give this a try. And after we do this, we'll do a question where we have to figure out another way to solve a quadratic, which is the quadratic formula. You all did that in school already?
So can you repeat?
The quadratic formula.
Yes, sir.
Cool. Organize. So let me expand on this one. Y, good Lord. Y is equal to 3, open bracket. I'll use the shortcut method again to expand the brackets inside. I'll get 4y squared. 4 2s are 8y. 8y by 2 is plus 16y plus 16 plus 4y plus 8 minus 1. Y is equal to 12y squared plus 16 by 3 is 48y. 16 by 3 is 48 plus 4y plus 8 minus 1. Now, Tyrese, I see you had y is equal to all of this here. But I want to get ax squared plus bx plus c is 0. Well, in this case, it'll be ay squared plus by plus c is equal to 0. So I'll move everything on the left. I'll end up with the y remains there, minus 12y squared minus 48y minus 48 minus 4y minus 8 plus 1 is equal to 0. So you're seeing your dilemma, Tyrese? I can add the y squareds to y squareds. I can add the y's to the rest of the y's. And I could add the numbers to the numbers. I'll end up with minus 12y squared. Y minus 48y is minus 47y. Minus 47 minus 4 is minus 51. Minus 48 minus 8 is minus 52. I'm sorry, minus 56. Minus 56 plus 1 is minus 55 is equal to 0. Tyrese, you seen a problem?
Yes, sir.
Nice. All right. So this is what I want you guys to do for me for our next class. I'm putting a couple simultaneous equations here, right? You all don't have to solve them. If you're comfortable using the quadratic formula, by all means, go ahead and use it where needed. But all I want you all to do, for example, in number 1, substitute 1 into 2 because I have y is equal to something in both cases, and rearrange, make it look like a quadratic. Instructions for number 2, you have in equation 2 over here, for this one, equation 2, I'll substitute 2 into 1. For this one, what I'll do from equation 1, I go say, well, y is 7 minus x. Then I'll call this 3. I'll substitute 3 into 2. And all I want you guys to do is to perform this substitution method for all of these questions and make them look like a quadratic. In our next class, we will attempt to solve all of these here, where we will get enough practice in solving quadratics, as well as practice in a quadratic formula. All you good with that?
Yes, sir.
All you know,
Yes,
all you
sir.
work. So dedicate some time, do questions 1 to 3, very, very easy stuff. I will send the recording, I'll send the notes, and I'll go see you all in the next class.
All right, let's do it.
Laters.